Of chemical kinetics. Today's topic is Arrhenius equation. Now, before going to this equation, let us go to some basic terms first, like activation energy, threshold energy. Let us go to these terms first. Now, suppose we have a reaction A plus B. Suppose they have to combine, they have to react and form products. Now these are reacting molecules which have to react. Now these reacting molecules, they have certain amount of kinetic energy, and that kinetic energy, they have that average kinetic energy. So your reacting molecules have average kinetic energy. But in order to happen this reaction, they will have to add some amount of energy so that it crosses a certain barrier, energy barrier, which you know that for a reaction to take place, the reacting molecules have to cross an energy barrier so that a reaction takes place. Now, in order to cross that energy barrier, these reacting molecules, they will have to have energy, a certain amount of energy which must be added to it so that it becomes equal to another energy, that is threshold energy. Threshold. This threshold energy is the energy which a reaction crosses. This is the minimum amount of energy that this reaction should cross. This barrier should be crossed so that a product is formed. In other words, I can say that the kinetic energy of these reacting molecules plus this energy which must be added to it, this energy which is added to it, which is given to it, so that it becomes equal to threshold energy. This energy is known as activation energy. So this energy, what is the activation energy? This is the energy over and above this energy, over and above this average kinetic energy. So activation energy is the energy which is over and above the kinetic energy which the reacting molecule should possess, should have, so that that energy becomes equal to threshold energy, and then that reaction crosses this energy barrier so that products are formed. So kinetic energy plus activation energy, that is equal to threshold energy. It must be kept in mind. So for a reaction to take place, a reaction requires activation energy so that these two energies become equal to threshold energy, and then your reacting molecules, they collide, because in a reaction to take place, the reacting molecules should collide. As per collision theory, we have already read that. In collision theory, we read that these reacting molecules, they must collide for having effective collision. When there is effective collision, then products are formed. So this is all about this activation energy. Now, Arrhenius was a scientist. He gave a relationship between rate constant, K is a rate constant, or velocity constant, and the absolute temperature of a reaction. So Arrhenius gave a relationship between rate constant and absolute temperature of a reaction, and that relationship between these two is known as Arrhenius equation, after the name of the scientist who gave this concept. Now what is this equation? How he gave the relationship between the rate constant and the absolute temperature. That equation, that is your Arrhenius equation, is given by K equal to AE negative EA upon RT. Now we have certain terms in it. Let us take them one by one. Here K you know, K is a rate constant. Then we have A here. A is again a constant called frequency factor. This constant is known as frequency factor. Then we have another factor other than A, that is this portion. This is another factor. This is E negative EA upon RT. This is another factor, and this factor is what? This factor corresponds to the fraction of molecules that have energy equal to or greater than, rather let us write greater than activation energy, EA. So what is this factor? This factor corresponds to fraction of molecules that have energy greater than this, greater than activation energy, which we know this is the amount of energy that reacting molecules must have, so that energy becomes equal to threshold energy and a reaction takes place. Then we have here EA. EA, you know, it is activation energy. And then we have another constant, that is R. It's a gas constant. So these are some terms in it, whereas A is a constant called frequency factor. Then we have this factor, this whole factor. This factor corresponds to the fraction of molecules whose energy is greater than activation energy. And then we have R and T. R is a gas constant and T is the absolute temperature. Now, if suppose K1 and K2 are the rate constants, these are rate constants, at two different temperatures. We have two rate constants at two different temperatures. Say T1 and T2. If we have this situation, that we have K1 and K2 at two different temperatures, T1 and T2. In that case, your Arrhenius equation that can be put as this: log of K2 upon K1, that is the ratio, equal to activation energy upon 2.303 rate constant, this gas constant, into reciprocal of T1 minus reciprocal of T2. This is again Arrhenius equation. This equation is at that very time when we have K1 and K2 as rate constants at two different temperatures, T1 and T2. So this is Arrhenius equation in this at this rate constant, that is K1 and K2. Now concluding the unit of chemical kinetics. Let us find today the units of rate constant. Unit for rate constant for different orders of reaction. We have zero order reaction, then we have first, second and third order. We can find the units of rate constant. Rate constant means K. We have to find the units of K for different orders of reaction. So let us first take zero order reaction. How we can find its units? You know, for a zero order reaction, the rate of a reaction is equal to rate constant into molar concentration of reactant. A is reactant here, and you should know that its power should be 0 for zero order reaction. In this type of reaction, the concentration has no effect on the rate of the reaction. Now this is rate. Rate you know, this is delta X upon delta T. That is change in concentration upon time. So as far as concentration is terms, its units are mole per liter. So here I shall write units of rate, that is concentration upon time and second for time. So instead of rate, I have written the units of rate. Rate you know, this is rate is equal to change in concentration of X upon change in time. So unit of time is second and that of your concentration is mole per liter. Now moving to this, K multiplied by this, anything raised to power 0 is equal to 1. So 1 into K, so it is K. So what are the units of K now? The units of K is mole per liter. Second will go to numerator and its power will be changed. It will be -1, that is per second. So the unit of rate constant for zero order reaction is mole per liter per second. This is all about unit of zero order reaction. Similarly, I can move to unit of first order reaction. Let me take first order reaction. First order, I have to find the units. For first order reaction, rate is equal to K, that is rate constant, molar concentration of reactant A raised to power 1. No need to write 1, it is already 1 here. Now let us find the rate. This is rate. What is the unit of rate? Again, mole per liter per second. Mole per liter per liter upon second. Then K, this is molar concentration, mole per liter. Unit of concentration is mole per liter, mole per liter. Now we have to find the units of K. So bringing K to here, the K will be equal to mole per liter upon second divided by, this will go to denominator, mole per liter. Now it will be equal to, now see, this is mole per liter, this is mole per liter. They will get cancelled. So you will have 1 upon second. If you bring this second as numerator, its power is 1, it will become -1. So what will be the unit? Per second. So the unit for K for first order reaction is only per second. So similarly, let us move to second order reaction now. Second order. Unit of rate constant for second. For second order reaction, rate is equal to what? K into molar concentration of reactant A raised to power 2. This is the second order reaction. Now moving to their units. Rate you know, that is delta x upon delta time, mole per liter upon second. K, molar concentration, that is mole per liter, raised to power 2, that is 2 times mole per liter. Now bringing this K to the left hand side, because we want to determine its units, it will be mole per liter upon second, and mole per liter how many times? 2 times. It will go to the denominator here. Mole per liter 2 times. Mole per liter into mole per liter, that is 2 times mole per liter. Now this mole per liter and this mole per liter shall go, and what will be left behind? It will be 1 upon S and mole per liter. Bringing them as numerators, this will be L. This is minus, this will become what? Plus. Then mole, this is plus 1, this will become minus 1, and second will similarly become minus. So this will be liter per mole per second. This will be the unit of K for second order reaction. And finally, let us determine the unit of rate constant, unit of K for third order reaction. For third order reaction, rate of a reaction is equal to rate constant, molar concentration of reactant, raised to power 3 for third order reaction. Now moving to their units, rate delta x upon delta t, or we can write delta x upon delta t, write this like this, then K, A raised to power 3. Let us move to their units now. This is mole per liter, that is concentration, upon second. Then K, mole per liter raised to power 3. Now K will be equal to what? K will be equal to mole per liter upon second, and this is mole per liter how many times? 3 times. It will go to the denominator 3 times like this. Mole per liter into mole per liter into mole per liter. Now this mole per liter and this mole per liter shall go. Now what is left behind? 1 upon second mole. Now this is 1 mole 1 mole 1. This will be mole square. When bases are same, powers are added. Similarly, so far as your L is concerned, liter, again bases are same, powers can be added. It will be minus 2. Similarly, it will be like this. Now what we get? Bringing liter to the numerator, I will get L square. Minus 2 will convert into 2. Then mole, this is minus 2, this will become minus, this is plus 2, this will become minus 2, and second will become minus 1. So these are the units of K for third order reaction. With this, we conclude this unit, that is chemical kinetics. Thank you very much.